Good day to our lecturer, Dr. Leonie, and to all my group mates. My name is NOOR SHAHZLIN BINTI SAHIMIN, and I am the leader of our group. Today, we will presenting our interactive web application hosted live on GitHub pages. Good day. We'll start the presentation first. For my project, I have built a web simulator titled Paddy Crop Biomass Dynamics and Derivative Calculator, which focuses specifically on analyzing the growth velocity of MOHD MR297 cultivar in the Mada granary located in Kedah, Malaysia. Let's address the bioscience problem in agricultural food security. Relying purely on raw harvest yield data only represent in the finish line. The proactively safeguard Malaysia's paddy self-sufficiency level, which currently targets greater than 75%, ergonomists cannot just look at the final weight. We must study growth velocity. By utilizing the first derivative, fx, of cumulative paddy crop biomass over days after transplanting, we can identify the exact extent of the maximum growth rate, also known as the inflection point. The agronomic application here is critical matching nitrogen and fertilizer top grazing schedules precisely with this peak vegetative velocity maximize fertilizer uptake efficiency. This directly prevents toxic nutrient leaching into local Malaysian waterways and significantly boosts overall grain panicle size, directly impacting our national food security. To simulate this, my web app uses a cubic growth model based on standard nitrogen treatment datasets from MOHD's research papers. The cumulative dry matter biomass function is grams per square meter is best modeled as fx equals negative 0.001 x cubed plus 0.15 x squared plus 2x plus 15, where x represents the days after transplanting in a range of 0 to 100 days. By applying calculus rules to find the instantaneous growth rate, we derive the first derivative function. This derivative equation gives us the exact growth velocity in graph per square meter per day at any given day x. There is 3 scenarios, but I will just go with scenario A. Now let's deeply analyze the live dynamic data for scenario A, optimal nutrient management. Starting at day 0, right at the moment of transplanting, our real-time calculator shows an initial biomass of 15 grams and a starting growth velocity. Next, as we drag the slider forward to day 50, we encounter the most critical biological milestone of the model. At day 50, the cumulative biomass has risen to 365 grams, and the growth velocity peaks at an absolute maximum of 9.50 grams m2 per day. Mathematically, this peak in the derivative curve is the inflection point of our cubic growth function. This indicates the precise moment where the crop is gaining dry matter at its fastest possible rate. Finally, let's look at the day 74 to see how the trend behaves later in the cycle. Here, the cumulative biomass has increased significantly to 579.2 gram M2, but notice that the growth velocity derivative has started falling, dropping down to 7.77 gram per day. This downward trend in the derivative represents the transition from growth to grain development, specifically during the heading and flowering stage. To conclude, as required by the presentation guidelines, I would like to recommend one way to make this HTML application better. In the future, we could integrate an automated push notification or email alert system via JavaScript. If satellite telemetry data detects a deviation from this optimal derivative curve, an automated alert would immediately notify farm managers to adjust their watering or fertilizer system in real time. I will hand over the next presentation to another friend. Thank you. We'll start.
Good evening to our lecturer, Dr. Leonie, and my group mate. My name is Heyn Boni, and today I will presenting my HTML project titled Malaysian Paddy Crop Growth Velocity Simulator, a tool designed for food security and bioscience mathematical modeling. Okay, the bioscience problem I chose focuses on the on the food security sector, specifically tracking crop yield accumulation and determining the precise fertilization schedule for Malaysian MR297 paddy. In food security planning, tracking this dynamic is critical to maximizing national rice yields. Why this project is important because traditional farming relies heavily on calendar guesswork, which leads to massive fertilizer wastage and local runoff pollution. Paddy biomass growth follows a non-linear sigmoidal logistic curve. By calculating the first derivative, we can find the exact growth velocity. This mathematically reveals when the crop hits its peak nutrient demand phase, allowing the precision nitrogen application to optimize cost and secure food production. And now let's see how this HTML application works interactively. Okay, on the left column, the system displays the biological context on the MR297 cultivar alongside the exact calculus formulation for the total accumulated biomass and its growth velocity derivative. And below that, we have the interactive sliders using tweak the biological parameters in real time according to farm condition, adjusting the max biomass yield, the inflection midpoint, and the growth rate constant. Okay. On the right column, we have the line chart updates dynamically. The solid emerald line tracks the cumulative biomass, while the dashed amber line tracks the daily growth velocity. Okay, the system also feature on interactive nodes analysis. If I click on any specific day along this curve, for example, here at day 60, the dashboard instantly extracts the real-time data. It breaks down the mathematical formula string, identifies the current growth stage, and generates an automated agricultural advisory note. In closing, my suggestion for improving this HTML page in the future is to interrogate a live weather and solar radiation API. Currently, the parameters like this growth constant are adjusted manually via sliders. Connecting it to live meteorological data would allow the simulator to automatically recalculate and predict growth rates based on real-time environmental factors in local rice yields. Overall, the simulator successfully bridged the gap between calculus and bioscience into an intuitive, accessible digital platform for food security planning. And that's all from me. Thank you. Good.
Good evening, everyone. My name is AIMAN Muhammad RIDHUAN CHAM. My metric number is F25A1950. So I take course SFP and we can call Technology Product Agro. So my topic is optimus palm oil extraction. So number two, summary of the chosen bioscience problem. The chosen bioscience problem in product technology is the inefficient extraction process of palm oil during the production of palm-based product. Some oil is still left in the water after process, cause loss of yield and raw material wastage. This problem affects the palm oil product industry in Malaysia because the inefficient product can increase manufacturing cost and reduce the quality of the final product. In addition, it may also affect the country economy since palm oil is one of Malaysia's major export product. Number three is important of study this problem. So study this problem is important in product technology because it helps improve the efficiency of product palm based on products such as food, cosmetic and industry material. With a better extraction process, more oil can be produced without increasing the use of raw material. This helps reduce waste and support food security as well as the development of industry and food technology. The rate of change or derivative is also important because it shows how the extraction yield change based on factors such as temperature, pressure and processing time. By understanding the reactive, manufacturer can determine the most optimal condition to produce high quality product more efficient and quickly. So we can see the graph over there. We can see my graph for optimal palm oil extraction. Day by day, we move increase like day 7.1. We can see the calculate the active 0.0.7 ratus all increase day, and we can see the the 115 remove increase for 0.323% or increase day. So recommend way to make him this HTML better is like one way to improve the HTML website in the future is by adding interactive feature such a slider to adjust the picture or processing the time and display graph change in real time. This will help product technology students better understand the relationship between processing factor and production yield in a more engaging and interactive way. So that's all for me.
Assalamualaikum
My name is
and good evening. My name is Sri ARINAH binti ABIDIN and my number is F35A 2021 from the SFM Food Security Program. Today I want to talk about how we can use maths to help solve a big problem in Malaysia farming. My topic is the rate change of in rice rate compared to fertilizer used in Kedah. Kedah is the most important place for growing rice in Malaysia, but many farmers there have a big problem. They use too much chemical fertilizer. They think that more fertilizer always using too much fertilizer cause big problems for our country. First, it wastes a lot of money for the farmers. Second, the extra fertilizer goes into our water and soil, causing pollution. Lastly, it ruins the soil and actually lowers the total rice production. If we don't have enough rice, our country food supply will be in trouble. Third important of studying in this problem, because this where the rate of change or the rate becomes efficient. The rate helps us calculate exactly how much the rice set respond to very additional kilogram fertilizer. By analyzing the mathematical rate, we can pinpoint the optimal point exists threshold where fertilizer efficiency is at its peak before entering the phase of diminishing returns. This prevents wastage and protect the soil. Now, let's look the interactive graph on my HTML website. The point when we the derivative positive and high, this means at the starting phase the crops respond very well and yet increase rapidly with each added unit of fertilizer. The middle point, as we move to the peak, the curve flattens out and the derivative equals 0. The represent the maximum efficiency yield. Adding more fertilizer beyond this point will not increase product. The final point at the of the graph, the derivative becomes resounding negative. This negative rate proof that over fertilization has caused soil toxicity, damaging the crops and causing the overall yield to drop. To improve, recommend one way to make HTML better. To improve the HTML website in the future, I recommend adding an interactive input slide or text. This would allow farmers to input the actual fertilizer data, and the system would automatic calculate the leaf derivative weight to show an instant alert like warning to pass on your limit. In conclusion, integrating calculus into agriculture is vital for securing a sustainable food supply for Malaysia. This is for me. Thank you.
That's all from our group. Thank you. That's all.